Hi and welcome to a very cool tutorial about the new programming language Swift, which is for iOS and macOS development. And if you're new to iOS or macOS development and decided to start learning Swift, or if you're an experienced Objective-C developer who wants to know more about the syntax of Swift, then we're going to do just the right thing in this tutorial. We're focusing on functions, methods, and classes in this tutorial, and how we're doing that in Swift. And I'm also going to compare it to the way we did it in Objective-C. So let's get started using the new playground feature of Xcode. Just a quick note and a quick hint at this point, we're going to use some UIKit classes in this tutorial. You can create a playground two different ways, using the welcome screen or using the file menu, new file. Some people commented that if they were using the welcome screen to create a playground, Xcode imported Cocoa, not UIKit, and if they replaced Cocoa with UIKit, then there were some problems, compiling problems. So to follow along, just create a playground using file, new file. All right, let's remove this first statement, which is provided by Xcode by default, and let's talk about how you access methods of classes or objects. Let me show you an example of a standard UIKit class, which you have used actually 1,000 times, UIColor. In Objective-C, you would have written UIColor, myColor equals, for example, UIColor red color. And that would have given you a UIColor object with a red color property. So how would you do that in Swift? Actually, you can get rid of the brackets in Swift, and we're going to create the same object using Swift syntax. So we are going to say var to create this object. Let's also call it myColor, and it is of type using a colon. It is of type UIColor. So this is how you define a type. You do not always have to define a type, because Swift can automatically detect what kind of data type you're using as soon as you initialize it. But I'm going to be type safe here and always give a type for an object. So let's now access the red color method of UIColor, and we're just doing that by writing UIColor.red color, and that's it. And notice how cool this is, getting the preview here, seeing what color actually this is by getting the RGB values, and that's pretty cool, using this this preview area here on the right side. So let me give you another example. Let's say we're going to use a UI button, using a colon to specify the type, and this is a UI button. And to initialize it, you can either use one of the convenient initializers, directly saying you want to initialize it with a frame. You can also just use this standard initializer, and afterwards set the different properties. And this actually follows the dot syntax, which you already know from Objective-C. So let's say myButton.frame equals cgRectMake, and give it some values here. So let's say 0, 0, 120. Okay, that's how to access a property of an object. And now let's call a method myButtonAddTarget, for example. And this is I'm not going to write all that stuff, all these parameters now into this method. Let me just give you an example. So you open the parentheses and can define the parameters you want to give your method. Like target would be self, the action selector, which you would write in a productive app. You would write into quotes like button clicked, button tapped. If there is again a parameter in your function you have written, then you would say colon after the function name. And for control event, UI control event touch up inside. And you see, you do not need to write any brackets. You just use dot syntax to access the properties and the methods of an object. So let's create a very simple function to get started. Let's just say function say hello. And we now can give our parameters or put our parameters in parentheses after the function name. And we will say, okay, we will greet someone. So let's say there is a name and this is a string. And we do not want to, let's say we want a return value, and the return value is specified by a minus and the greater than sign, and specifying the type. And again, we want to return a string. And in this case, we just would write return hello, using now another kind of concatenation operator, which you do not know from Objective-C, which is the backslash, and then parentheses, name, and this will return, this will concatenate the string hello with name in our parameter list. And we could also actually say return hello plus name. Is also something that would work. Now we get this this warning because we are already returning something here, and when we call the function say hello, we put in a name, let's say Brian, and we get hello Brian. And as you can see, you can concatenate strings that way or that way. If we have a look at the preview in our playground, both is working equally. Now let's get in touch with some of the cooler features of Swift regarding functions, because we can add an unlimited number of parameters actually to a function of the same type. So let's say we want to create a sum of some numbers, and let's create, let's call this parameter numbers. These numbers should be integers, and by writing 3 dots, we indicate that we can pass in as many numbers as we like within an array. And we want to return this sum as an integer again, and open this function up. And now let me just create a variable, call it sum. It is of a type integer, and we'll set it to 0. And then let's return the sum. And now what we can do is iterate through this array of numbers and say for number in numbers. And what are we going to do? Well, we're going to add the number to the sum. Plus equals, the same as in Objective-C, number. And if you haven't understood it until now, I'm sure that you're going to understand it in a second when I call this method, when I say sum of, and now I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and whatever, and we're going to get the sum of 55 because we are giving this function an array and we're iterating through this array within our function, and that's pretty cool stuff. Well, let me show you another thing that is new with Swift and which is really cool. You can actually nest functions in one another, and you can also have a function as a parameter within Swift. So let's create a function that is called has any matches. This function actually checks whether in a given array of numbers, whether they match a special condition that we're going to define. So we are going to have an integer array, which is specified by the brackets here. We'll call it list. And we're going to have a condition. And this condition will get an integer as a parameter and return a bool. And the function has any matches will also return a bool. So this parameter is a function by itself. So what are we going to do? We will say for an item in our list of numbers, we're going to check if the condition is true for item. And if this is the case, then we'll return true. And the function will break up if we have returned, and in another case, let's return false. So, now what about this condition? Well, this is another function actually. Let me give me some space here. So let's create such a function. Let's say function, our condition is less than 10. And this function can obviously get a number, which is of kind int, and will return a bool. Not this kind of object, bool. And we will just return number less than 10. And we will compare, so this is a comparison. If the number is less than 10, then we'll return true. And we can now say, for example, var numbers. This is going to be an array of numbers equals. And now let's give it some numbers, 20, 19, 7, and 29. And now let's call our has any matches function as any matches. So now we are giving this function its array of numbers, and as a condition we are just writing in the condition function less than 10 without any parameters and without parentheses, and we will return true because there is one number 7 which is less than 10. So if I am going to write 11 here, then we'll get false, because there is no number in this array that is less than 10. And what it does is calling our has any matches function, which requires as a parameter a list of numbers as an integer array. We're then iterating through this list, and for every item in this list we check the condition, which is another function. And this condition function must have an integer as a parameter and must return a bool as a return type. And so if this conditional function returns true, we are returning true and has any matches. So it is going to be really easy to write another condition just by defining another function. Now let's say function greater than 30. Again, we have to give it the same structure, so we have to give it a number, which is an integer, and return a bool, and return number greater 30. And if we then call, let me change that here, if we then call this greater than 30 function here, then we're going to get, again, false, because there is no number greater than 30 here. And let me change another one this time. Let's say this one, 31. And now we are going to get true, because we have defined this greater than 30 function as our new condition for our has any matches function. Okay, now you have seen how to access methods, how to write methods or functions actually, and how to use some of these cool new Swift features. Now let's get started and use some of the let's get started creating some classes within Swift. We will start with a basic class, which is going to represent a shape. So we have to call the class a keyword and name our class, which is shape. After that, we can open curly braces and define our properties and methods. So let me start with the number of sides for a shape. So var number of sides, which is an integer, and we will give it 0 as an initializing value. We will then give this shape a name, which is going to be a string. And now we will just define a simple function, which will be a simple description, which will return a string and have no parameters. That's cool. Let's restart our playground. Let's hope that there are some things left. Cool. At least some of our things are left. We will have to rewrite the class. So let's again call class. It was shape. And we had already a property which was called number of sides, which was an integer and was initialized with 0. And we also had a name, which was a string. And what we wanted to do was to create a function that gave us a simple description of our shape. It had no parameters, but returned a string. So what does our function do? Actually, it just returns a shape with, let's use this style, number of sides. So as you can see, we can access all of our properties within our functions. And now let me see what's wrong here. Yeah, this error is pointing at a problem because we haven't initialized our name property yet. And we're going to do that in the initializing function, which is always called when an object of this kind is created. So this is init. And init can have multiple parameters, so let's call it parameter name, and this is a string. And let's open the curly braces. And this time, because name and name both have the same name, actually, yes. Because of that, we have to access our property of our class using self, and now we can say self.name equals name. And with this, we have initialized our property name of the shape. And as I said, you can access all of the properties of your class within all functions of this specific class. So actually that already is our very, very basic first class. Let's create another one which is going to inherit from this class shape, and this class is going to be called square, which is a special shape. So we're going to inherit from shape using a colon after a class name. And now again in curly braces we can now define properties and methods. In this case we're going to have a property with a side length of our square, and this is going to be a double. Now let's also create a initializing method for this class, so let's call it init. It's always init. And in addition to name, which is inherited from our shape class, we're going to give this, of course, a side length of type double. We have to separate the parameters with a comma and open the curly braces. Now let's say self.sidelength equals side length. And because name is also initialized in our shape class, we have to call super name equals super init and initialize our shape class with the name. All right, and we can actually access all the properties that are inherited from our shape class. So let's say number of sides is, of course, within a square of 4 sides. And now what can we do with a square? There are some more possibilities than just a simple description. We could, for example, calculate the area of this square, and this is going to return a double. Oh shit. All right, let me save that. Hope nothing else happens. Let's open the curly braces and just return side length times side length. All right, and now we want to override our simple description function to give a little more detail, because we're now within a square. So let's type override. Or if we're lucky, we can just say simple description, and now autocompletion works great, because we can just autocomplete this method, and we have the override statement, which has to be placed before func to indicate that this is an overridden method that is because it is an inherited method from our shape class. So let's return a square with sides of length, and again use \parentheses side length. All right, this is our very simple square class, and let's create an object of it. So let's say test. Now this is a square object in square, and use our initializer, and it has a side length of, let's say, 20, and we'll call it test. And now if we say test.simpleDescription, we will get a square with sides of length 20. And we could also actually say test.area, and we would get 400, because 20 times 20 is equals 400. And now let's inherit our shape class one more time and do some pretty interesting stuff with getters and setters. So let's say we have another class which is called equilateral triangle, which is also inheriting from shape. And our triangle is going to have a side length. Again, type double, initialize it with 0. And we're again writing an initializing method. This time we're going to need, again, a side length. Type double. And we will then say self.sideLength equals side length. We will call super init. We'll give it the name of our triangle, and then we will say let's say number of sides in a triangle are of course 3. Now we can also have another property within a triangle, which is the perimeter. So let's create a perimeter of type double, and now we can do some really cool things. Opening a code block with curly braces after the data type, and we can now specify what should happen if we want to access this perimeter property. So we could say when we use the parameter as a getter, we can, again with curly braces, specify what should happen, and we want to return 3 times the side length, which gives us the perimeter. And if we use this property as a setter, we are going to set the side length to new value divided by 3, which gives us the side length. Now this is pretty cool actually. And And let's do one last step now here, overriding our simple description again. Return an equilateral triangle with sides of length, and again use this syntax, side length. All right. And now let's say we're content with our new function and create a little test object. Let's say call it triangle, which is an equilateral triangle, and initialize it with equilateral triangle and a side length of, let's say, 2 and a name of try. All right, now let's say triangle dot perimeter, and we will get the perimeter of 6 because we have 3 times the side length of our equilateral triangle. And if we then say triangle dot perimeter equals 4.5, for example, and we will then again say, for example, side length, we'll get 1.5 because the side length of an equilateral triangle with a perimeter of 4.5 is 1.5. Well, and that's really cool to use getters and setters this way, because you don't have to write a function for that kind of stuff. Now you have seen quite a lot of things about methods, functions, accessing methods and properties, write your own custom functions, using the new Swift technologies and new Swift code to get as most out of the new features as possible. And the video is again very long, but I hope you liked it. And if you have any questions, feel free to comment below. And if you have questions, also feel free to comment. Thanks.